As we prepare for the exam, we're going to take a review of each section that we've covered thus far, starting with the section on functions. With functions, we first asked ourselves to determine if it is a function or not. Is it a function? And I'm going to draw a couple graphs on here. Let's do 4 of them. And we'll talk about what's needed for the graph to be a function. Let's say we've got this one. Let's say we've got that one. Let's say we've got this one. And let's say we've got this one. Well, in order to be a function, we should be able to draw a vertical line through the graph and only hit the graph once. So you notice this first one, wherever I draw a vertical line, it only crosses the graph once. So we can say that one, yes, is a function. But the second one, we crossed the graph 2 times. So no, that is not a function, because every input is only allowed a single output. Here, if I draw a vertical line through the graph, we cross 3 times. So that one's not a function either. But the last one, no matter where I draw the line on the last one, it only is going to cross once. So that means, yes, it is a function. Once we got comfortable with this idea of a function being every input has at most one output, we could start looking at functions like f of x equals x squared minus 4x plus 1. And then we could evaluate various inputs on the function. Maybe I want to evaluate f of negative 3. Well, whatever is inside the function can replace our x's. So we have negative 3 squared minus 4 times negative 3 plus 1. Doing the exponents, negative 3 squared is 9. Negative 4 times 3 is a positive 12. And then we've got a plus 1 at the end, which adds up to 22. But we could make it more interesting if we didn't just want to plug in a value. We could plug in an algebraic expression. We could evaluate f of 2x minus 3. And in that case, we would take the 2x minus 3 and plug it in for both of the x's. So we have the stuff squared minus 4 times the stuff plus 1. That stuff is the 2x minus 3. Then we can work to evaluate that. When we square, we get 4x squared minus, we multiply those together and get negative 6x, and it's there twice, giving us negative 12x plus 9. Distribute the negative 4 through, and we get negative 8x plus 12 with a plus 1 at the end. All I have to do to finish simplifying is just combine like terms. We've got the negative 12x and the negative 8x is negative 20x. Then we've got 9 plus 12 plus 1. That's going to be plus 22. So that is our simplified expression for f of 2x minus 3. Another thing we did in our chapter about functions is we reviewed how to find a line that goes through several points. Let's say we have a line that goes through 2, negative 3, and negative 1, comma 9. And we want the function that connects those 2 points. Well, we found out with lines, we need to first find the slope. And the slope was the y2 minus the y1 over the x2 minus the x1. So in this case, it's going to be 9 minus negative 3 over negative 1 minus 2. Changing that to a plus, we've got 9 plus 3 is 12 over negative 1 minus 2 is negative 3. So my slope here is negative 4. Then we know the equation of a line is y equals m times x minus the x-coordinate plus the y-coordinate. So plugging in what we just found, we get y is equal to the slope of negative 4 times x minus the x-coordinate of 2 plus the y-coordinate of negative 3. And if we wanted to put that in slope-intercept form, we could just distribute and combine like terms. So we have y equals negative 4x plus 8 minus 3, or y minus negative 4x plus 5. That was a quick review of our chapter about functions. In our next video, we'll review our chapter about limits.